It's always trained on the last 12 months.
And getting this inception thing going on here where you're running analytics on your analytics.
Exactly, yes. But that's what's going to keep your model fresh based on the latest data. And you still want to have that model monitoring because maybe something else is happening.
Hey there, everyone. My name is Gary Spakes from Rich Trail Ventures, and I'm on Brian and Brian's channel from Value Driven Analytics. This is another video that we're talking about in the analytics lifecycle space that's out there. Brian, have you had fun so far?
Oh, it's been a blast. This is a unique format. Usually it's just me going on and on about analytics, having no...
You're just talking about data preparation when we established that with all the SQL stuff that you got going on. And I think we're trying to elevate that conversation through here, right?
We're definitely elevating it. We're raising the bar for the channel. This is where the rubber meets the road when it comes to analytics and data science.
Yeah, you've
been great.
You've thrown a lot of terms out that I have been refreshed on in this process over this video series.
And you're reminding me of how important it is to not just talk about the techniques, but actually what comes next after you write the SQL. That's been a great conversation.
Yeah, and I know the last time we talked about turning an analytic model and moving it into production, and some of the struggles that organizations have between IT and the analyst community, or the line of business community, and how that can create shadow IT and associated like that. But I want to turn to analytic monitoring today and what that really is all about. Because, when I take a model and I move it into production, it's just, I don't have to worry about it anymore. Is that right?
Well, you would hope so. And perhaps if you baked in error notifications, if the thing runs into an error, your team is automatically being notified. That's very important. Perhaps for that first month or so, perhaps you are good. You've built the model, it's good. But what tends to happen over time, Gary, is these models degrade in performance. And the reason for that is the trends between your input variables and your target variables. Maybe it's different variables that are becoming important. Maybe it's the weighting of those variables that needs to change. Trends change over time. What was predictive of really, yeah, you'd be surprised. What was predictive of a target variable and 5 years ago might be completely different today. And so it's important to monitor that and eventually update your model coefficients.
You kind of like bell-bottom pants going out of style and back in style and then out of style again.
Well, that's a good example.
Cargo shorts.
Right. Right. So if you built a model to predict what some product someone was going to build, but you built it on something 30 years ago, your model's a little outdated. When you apply it today, you're probably going to come up with some predictions where someone says, yeah, maybe if it was 30 years ago, I'd buy that, but why don't you give me a coupon for something that I want today?
I got it. So, when we're thinking about monitoring these models, one of the things that we didn't talk about in the model build is looking at a lift chart. Mm-hmm. And that when you're running a model tournament, where a lift chart for our viewers is a good predictor of will this analytic technique work? And what you'll see is if you look at your data, you actually, I guess it would be for those, what's the word, the supervised models?
Yeah, the supervised when you're rolled out data.
Yeah, you got a 50-50 chance of hitting it across there. But with some of these analytic techniques, you might, instead of a straight line up that 50-50, you might get a 90 or a 92, or either that lift chart wanted to go up as fast as possible. I mean, are you doing that with your analytic models that are in production when you're monitoring those? Are you rescoring those things, or you're grabbing data? How does that actually work?
Well, when you build the model, you get some kind of a model performance metric. So it's a continuous variable. Maybe it's something like the sum of squared errors or R squared value. There's so many different model metrics model monitoring metrics. And we talked about a little bit in one of our videos about how that predictive power on another data set, the holdout data set that it hasn't been trained on, most of the time, now just due to random chance, it can sometimes be higher, but most of the time, there's at least a little bit of overfitting. It's going to perform, in general, the best on that training data set. So by the time, even the same time period, it's going to have a little bit worse performance, just a little bit. You expect that. You don't want it to be too much, or else you might have an overfitting issue. But assuming that it just degrades a little bit on your holdout data set, it's great. Now you've got that. Now you implement your model, and then imagine, I would recommend just having this set up as an automated process as part of running the model. You need to take your forecast for whenever you produce these forecasts, put them into a database so you have a historical record of what your forecast was in these different periods. And then of course, you're probably monitoring your actual metric in the database as well. Bring those together in a dashboard and calculate that model performance metric, R squared, for instance, and look at it over time. And what typically happens, Gary, is it does degrade. It'll probably be in line with what performance you saw on your holdout data set at first, as long as you've trained it on somewhat fresh data. But then what's going to happen maybe over the next few months or even years in some cases is you're going to see that probably degrade. And when it gets to a low enough level, that is time to refresh your model on a more recent data set, or you can automate this process and just have your model set up from the get-go to look at the latest data.
And then potentially rerun your your model tournament to then publish that new scoring algorithm, since it's just math automatically.
Right. It's always retraining based on the last 6 months or whatever time period makes sense. So whenever you get to a new month, for instance, your model, and if you need it to be more recent than that, it's always training on the last 12 months.
I'm getting this inception thing going on here where you're running analytics on your analytics.
Exactly. Yes. But that's what's going to keep your model fresh based on the latest data. And you still want to have that model monitoring because maybe something else is happening. Maybe something broke in a data set and you didn't even realize it. If you're monitoring the accuracy of your model over time, you'll see that where it gets below a certain threshold. Maybe you set it up not even where you have to go into a dashboard and see this. You can if you want to monitor it, but where if it gets below a certain threshold, you've set it up to send you an email. So you don't even have
so
to.
I'm going to chase a rabbit here now because you're talking about running analytics on your analytics,
Right.
To then move these things into the new production space. Is this broadly categorized as AI and ML, artificial intelligence, machine learning, where you've got these things that is that what's kind of going on? I mean, I want your opinion on it.
Well, those are, they've become buzzwords in our society, right? Everyone wants to put the term AI on things is the way what I've noticed. So it means different things to different people. I'll share with you how I think about those terms, and it's probably different than how other people. There's not a right or wrong answer here, but yes, definitely machine learning is what we're talking about. I would say artificial intelligence as well. But the way I typically define those is when I think about machine learning models. When I think about, I almost think about that as a non-parametric model, a model that doesn't assume a distribution. It's able to build on data sets that have all kinds of distributions. But another way of thinking about machine learning is it automates the feature selection, those independent variables, those predictor variables that you brainstorm and code out. A regression model, at least typically ran, you would tell it which models go into it, and it's going to define which variables go into it, and then it's going to assign a coefficient to all the variables by default that you give it. With a machine learning model, it automatically figures out which variables to include. The feature selection is automated.
So if I think about it then, and I could put a process together, I could take an association analysis and then pick variables that scored like 80% or higher.
Right.
And then feed those into a model tournament to pick the best model to then publish that and continually run that. And that's what you're talking about, a machine learning type thing. So as new data is coming in, it's always recalculating that association analysis to then give me the best model to then move into the production side of the house. That can get pretty complex.
It is complex. Though the more automated that process is, I would consider that to be more machine learning. Even regression models can be turned into like a machine learning model when you implement things like any kind of stepwise selection process, like forward selection. Now that's a process where it's automatically selecting the features for you, and that can be scheduled. So you've almost turned something like regression that sometimes is manually told, here's the variables to include, figure out what the right parameters are, and you've turned that into a machine learning model through forward selection where it's automatically selecting the variable.
But you still want to monitor the accuracy of that.
No matter what you're running. Exactly. And then
And why is that important?
it's because that predictive power naturally degrades as things can change over time.
The bell-bottom syndrome. That's what we're calling it. The bell-bottom syndrome.
I like it. That's great.
All right. Hey, you heard it here first.
Well, going back to artificial intelligence, and what does that mean? The way I've started to think about artificial intelligence versus machine learning is taking those features, automatically selecting the right ones, assigning weights to them, and so forth. Artificial intelligence, I kind of associate it almost with neural networks and different kind of deep learning models. And what deep learning does is it doesn't just take those input variables, it actually creates new input variables. Obviously, you've got... Yeah.
So we're back to data preparation again.
Well, the thing about this data prep is you absolutely have to give it a starting list of variables, but then it's going to create its own features. It's not just selecting the features among what you've given to it. It's now doing that data preparation for you, essentially, creating all kinds of versions of, well, what if if you're doing image detection, let's assign certain weights to these pixels and bring it together in another input variable. That's what deep learning, and that's when I start to think about artificial intelligence, where it's able to do just amazing tasks like image detection, sound detection, natural language processing. In order to do that and do that well, it's taking these feature variables and creating new feature variables based on that. And to me, that's kind of how I think about artificial intelligence, the differentiation between machine learning and then taking it to the next level with artificial intelligence.
Interesting stuff.
Yeah, interesting.
I mean, when you think about just monitoring something, you don't think about it can be that complex or that telling.
Right. Just put into production and we're good, right?
Yeah.
Not always. Yeah.
Hey, my name is Gary Spakes from Rich Trail Ventures. Brian, it's been a pleasure on this series with you to talk about data preparation and exploration and having to iterate back and then building analytic models, whether they're forecasting or data mining models that are out there, and then validating those models and moving them into production space, and to then get to the point where we're at now, where we've got production models that we're monitoring and possibly working with IT organizations inside of my business to make sure that that's an automated type of process to keep that whole engine running.
Yeah, there's a lot involved in the process. And what I would say to our viewers, decision makers out there, analysts as well, practitioners, if you need help figuring out what this process could look like for your organization, a lot of analytics organizations struggle to get to this point where they are deploying models and maybe they don't have monitoring systems in place. We can help you. Consider value-driven analytics. Consider Rich Trail Ventures. We're looking forward to partnering together. Please reach out to either one of us. We'd love to help. It's been a pleasure. If you like this video, please consider liking it formally. And also consider subscribing if you'd like to see more interviews between me and Gary and other analytics trainings. Finally, leave a comment. Absolutely. We'll try to answer your questions as soon as we can. Thanks again for watching, and see you on the next video.